I see that there is some wind rustling sound in the previous podcast. Sorry, you have to live with it because I have to live with this very hot temperature for making sure I live without an AC. So let's touch a little bit more on the genetic evidence. Obviously, we already mentioned how we use mitochondrial DNA to go back to, as they say, the mitochondrial Eve, the mother that would have passed all the genes down the line. So we already mentioned how nuclear DNA is inherited from all ancestors. So offspring carries 50% of each parent's gene, as we call alleles, and then as they breed we keep going down 50% each and so on. So this person here has collected genes in both the lines coming down to this particular baby, a child, whereas mitochondrial DNA is inherited from a single lineage, even though there is evidence that there can be contributions from the father as well. But nonetheless, it is typically used to go back to figure out the common ancestors and so on, which is obviously very important for hypotheses like out of Africa. And there is additional haplotypes formed, haplogroups. For example, when you say mitochondrial DNA being passed down matrilineally, the DNA has certain alleles on the chromosome which are inherited as a group. So as mixing happens, the haplogroups are formed across, and they can also be used to determine dominant haplogroups in native populations with possible migration routes. So you can see how various numbers of haplogroups are noted here. So Y DNA atom, and there is the mitochondrial DNA Eve kind of terminology that is used here. So you have Paleolake exposed land during the last glacial maximum. So various hypotheses are mentioned that could have led to the migration routes. Ice sheet during last glacial maximum, so Beringia and this path probably would have allowed the Clovis and so on during the last glacial maximum to come down here. And we will see a little bit later on that there is a big debate about whether there was a coastal route that led to colonizing South America, whether they got here through boats or they did use the land bridge, whether they really followed the coastal path, or because there are mountains here, mountains there, or they spread out quickly once making it into North American land. Of course, the migration and mixing went on even during the Holocene, with the Spaniards coming in and mixing with the natives and so on and so forth. So these are the coastal migrations implied here. Inland expansion through major rivers, so you can see many of the inland pathways, and maritime expansions as well. So these Polynesian and Micronesian islands got colonized literally in the last few thousand years, 3,000 to 5,000 years, like the Lopitas here, Marquesas Islands, Hawaii, and so on and so forth. So these colonizations obviously happened long time ago, because even Homo erectus and so on are found here, maybe even Homo ergaster and so on. And of course there were also hominin ancestors here. So only dominant highest percentage or notable haplogroups are shown. Haplogroup names are taken from this reference here. So the basic idea is that as migration happens and mixing happens, mitochondrial DNA and groups of alleles that get inherited create these so-called haplogroups. So then one can go and see who the Japanese are related to from the past, who the North Chinese and the South Chinese are related to, who the Russians are related to, who the Clovis, what genetic haplogroup did the Clovis bring into the New World, and so on and so forth. And of course all the genetic material that got out of here and got spread, mixed, bottlenecks, genetic drifts, and so on and so forth. So along with the genetic evidence, which is not as extensive as we go back in time, we begin to also mix evidences of morphologies of tools, for example. So these are Aurignacian types and various other morphologies or preciseness and materials used for making the stone tools and so on. So the upper Paleolithic tools and the more recent ones are then used to try to see if there was commonality, if the production went up, if that indicates social connectivity across various sites, let's say just in Africa, and whether that also indicates growing technology and aptitude and expertise in using hands and maybe cognitive abilities, cooperation in terms of hunting big games, and so on and so forth. So in general, there are these modes defined. So mode 1, where just flakes are used. Mode 2, bifacial, so symmetrical tools. Mode 3, level was pre-prepared flakes and blades and hafed onto wood, so spears made for precise hunting and so on. So as time went on, complexity also increased, and always the question is whether this also corresponds to increasing cranium size, brain size, prefrontal cortex, whether there is behavioral change and feedbacks associated with the brain size as well, because of the use it or lose it kind of hypothesis, and whether the behavior also shows additional social skills, language, communication, and so on and so forth. So Stone Age, obviously, Paleolithic is going back to millions of years, where earliest use of stone tools was obvious, and then you have prehistoric, which goes before the written evidences of societies and behaviors and communications, and you have more recent divisions as Mesolithic, going from the end of the last ice age, dating to about 12 kilo years, to Neolithic, which ended very recently as the Bronze Age and Iron Age arrived. And of course then we got into Industrial Revolution and printing and writing and so on and so forth. So if we want to look at a little bit more detail here, 10 kilo year to 8000 BC, Starkar, a lakeside settlement in North Yorkshire with the earliest house in Britain. It would have looked like a tip, was almost permanently inhabited around 11,000 years ago. People wore red deer antlers in ceremonies, so some kind of a tribal structure was already there. Farming was developed in the Near East around 10 kilo years. This involved domesticating wheat, barley, and sheep, and as we said before, we don't know whether this was forced on humans by disappearing mammals, and lifestyle change had to happen from hunting and gathering to farming, or whether some other driver existed is not very clear. So Britain was finally an island around 8 kilo years ago, because there was an event which cooled and there was a dip, and then warming happened, so sea levels went back. So when sea level dropped, UK and mainland Europe would have been connected through land bridge, but once sea level went up, Britain was finally an island. Another tip-like teepee, I should have said teepee here. Another teepee-like house was found at Howick in Northumberland and dates to about 7600 BC, which would point to settle down livelihoods, agriculture becoming settlements, which led to changes in the way families were working together and not moving so much, fertility would have gone up, population would have begun to increase, children would have had more time with the parents and with each other, so learning would have happened that way as well. This Storegga landslide off the coast of Norway circa 6100 BC caused a tsunami on the east coast of Britain and flooded Doggerland. Farming reaches Central Europe about 7.7 kilo years ago to 5700 BC. So Levant and Far East, where agriculture seems to have evolved independently and then spread elsewhere. The earliest copper objects start being made in Europe around 7 kilo years 5000 BC. 6 kilo years to 4000 BC. Farming was introduced to Britain around 6 kilo years 4000 BC. This included domestic wheat and barley, sheep and cattle. Pottery was also introduced during the Neolithic, 4 kilo years or 2000 BC. Remember, we are in 2000 now, so when we say 4 kilo years ago, that's 2000 BC. I hope that's clear here as well. The earliest feature of Stonehenge, a circular bank and ditch, was started around 5 kilo years or 3000 BC. The stones came later. Skara Bay was also first inhabited in 3000 BC. So 4 kilo years ago, the Bronze Age begins around 4.3 kilo years or 2300 BC. The Amesbury Archer is buried near Stonehenge with the earliest metal tools and jewelry in Britain. The Iron Age in Britain begins around 2.8 kilo years or 800 BC, and the second Roman invasion of Britain in AD 43 is usually used as the end of the Iron Age and prehistory in Britain. Okay, so I will leave this here and then come back and start getting into some of the climate signals, which we will return to in the next chapter full time. But I hope it's clear that we use all the evidence we can get: genetic, morphological, anatomical, functional, behavioral tools and the changes in their tool structures, complexities, precision, and so on, to figure out human diaspora out of Africa or other speciations that may have happened elsewhere after immigration out of Africa. As I said, not all questions get answered precisely, but it's a complicated and long story with enormous amount of evidences being collected in different places, so the number of papers is really large. I'm filtering it all down, not going into details of evidence found in each continent. For that you'll have to read the book, and it is a very long chapter, but it's also very interesting. But since I want to focus on climate impacts, I'm going to go through the main material here and get to the next chapter where we start climate as a focused topic, but we will visit climate here as well, just to see what are the climate variabilities and changes that may be important for hominin evolution. Could have been drivers, and of course now we look at climate change as something that humans are driving actively, but in the past they would have done it implicitly in terms of their livelihoods. General assumption is that hunters and gatherers were not destroying habitats as much. But when you look at the evidence of flora and fauna extinction along the way, and I will come back to it later on in the course, that humans have affected ecological evolution as well. So we will look at some of those later on. Okay.